Hello my dear students, welcome to eCareerPoint-English medium YouTube channel. So how are you all? Hello Aman, hello Muhammad. So today we are going to start this new chapter, Laws of Motion, and this is an important chapter of mechanics in which you will learn about force. Hello Kavya. So before starting this session, I want all of you to quickly share this session to all of your friends so that everyone can take benefit of these free YouTube live classes by Career Point, especially for English medium students. Okay, so are you ready to start? See, this laws of motion, in this chapter, we are going to mainly discuss about the cause of motion. Okay. Previously, we were discussing about the kinematics. Kinematics, we have studied motion in one dimension. We have studied projectile motion. Okay, these we have already done, and these were the part of kinematics. In kinematics, we only consider the motion, not the cause of motion. But in laws of motion, we will study about the force, which is the cause of motion. Okay, so this chapter is very important for mechanics. And all of you know laws of motion, these were given by Newton, scientist Newton, who discovered gravity by observing a falling apple. Okay, so let's start this lecture. See, in these classes I am going to take some good example along with theory so that it can be beneficial for all of you. So those who can see, quickly like this session. All of you who are watching, like this session because it inspires us to give you a lot of good content. Okay, so like this session and share this to all of your friends using WhatsApp, Insta and Facebook. Okay, so let's start. So let me introduce to our toppers of NEET 2020. These four students, Vivek, Paras, Tanay and Jatin, they have secured under top 50 rank in NEET 2020, and they were the regular student of this e-career point coaching. That is our coaching from online coaching. Okay, and we have started a new course at a minimal price, as you can see. So this e-career point app is very beneficial. Either you purchase any course or not, you should download this app. Why? Because we have both free stuff and paid stuff on this app. Okay, how to download? Just go to Google Play Store and search eCareer Point without any space, and you will find this app, eCareer Point Learning App. Just install this and register yourself. After registration, you have to follow your expert so that you can attempt free questions posted by your expert for practice. And if you want all these notes, that you can see here, these slides, you can get here. You can get it from here. Free stuff. Go to free stuff and select medical because I'm teaching for NEET. And here, class 11th NEET 2022, you will find all the video lectures of mine of previous chapters along with the notes. Okay, so from here you can find. Yes, Kavya, it is available, as you can see. And if you want to see, we have both free stuff and paid stuff. If you want to purchase any paid stuff, just use code ST10 to get 10% discount. Okay. Hello, Dreamer Jack. I'm fine, thank you. Okay, and we are also available on several social media platforms. So you can join us even on Telegram. You can join us even on Telegram, where thousands of students are present here to discuss their doubts. So let's get started by this chapter, Laws of Motion. Okay, so let us discuss the first law of motion. See, what is the first law of motion given by Newton? This chapter is also known as NLM, that is Newton's laws of motion. So what is first law? According to this law, every body continues its state of rest or motion in a straight line unless it is compelled by external force to change the state. That is the first law of motion. That means, see, the first law says if this body is at rest, this will continue its state of rest until and unless there is an external force applied on it. Okay, or if a body is moving with some velocity v And if there is no force, it will continue its motion in a straight line until and unless we apply any external force. That is the first law of motion. Now, why it is written here straight line? If a body is moving, if no force is applied on it, why it is written that it will move in a straight line? Because, as you know, you have studied this thing about force in your previous classes, that force can change the velocity of any object. And because velocity is a vector quantity, so force can change either magnitude or velocity or both. So if particle's velocity is not changing either in magnitude or in direction, that means there is no external force. Okay. So if a body is moving, okay, just ignore the rotation of this body. If this body is moving, so it will continue its motion in the same direction with the same speed until and unless we apply any external force. Okay. So you might be thinking that there may be a frictional force in backward direction and definitely it will stop. So it depends. See, if it is moving with a velocity v, it will continue its motion with the same velocity in same direction if there is no external force. Generally, if we consider this situation on ground, then there is a friction force in backward direction. Okay, about friction force we will study in detail, but right now see, there is a friction force which decreases the velocity. But if there is no velocity, there is no force, there will be no change in either magnitude of velocity or direction of velocity. Okay, that is Newton's first law. Okay, so if a ball is moving, okay, you may think that will this ball stop? Yes, it will stop if there is an opposite force. Yes, about inertia you will study in second law in today's lecture. Okay, dreamer. So wait. So this is the first law, that if a body is at rest, it will be at rest. If a body is in motion, it will continue its motion without changing either direction or magnitude of velocity until and unless there is an external force. Okay, so this body will stop only if there is an opposite force. Suppose there is no external force on this body. Suppose net force is 0. If net force is equals to 0 on this body, it will not stop. Yes, if in a gravity-free space, if a body is moving and it is not experiencing any external force, none of the gravitational force, then it will continue its motion in a straight line. Okay, hello Devyani. So better like this session, all of you, those who are watching, like this session, because it inspires us to give you a lot of good content. Now, see this. This football was initially at rest. When we kick this football, so during the time of kicking, what we are doing? We are exerting force on it. So before kicking, the football was at rest. Why? Because this is the Newton's first law, that if a body is at rest, it will continue its motion in rest. Or if a body is moving, it will continue its motion in a straight line until and unless any external force is applied. So see, it was at rest. Now to change its state from rest to motion, we have to apply force. Okay, here we kick to apply force. So what is the force? Yes, Devyani, I know you were the second winner of last 20. Good, well done. So share those Menti session to all of your friends and inspire them to participate. Okay, we will take more Menti quiz, and because Newton's law of motion is a big chapter, we will take a lot of Menti quiz on it. So we can define force. What is force? Force is a physical quantity that changes or try to change the state of a body. See, here initially this football was at rest. Now to change the state of football from rest to motion, what we need to do? We need to apply force. Okay, So if we apply force, we may change the state of a body. Okay, it is not necessary that the force will definitely change the state. Net force will change, but a single force may change or may not change. For example, if I press this board, I am exerting force, but this board will not displace. It will be at rest. It doesn't mean that I have not applied force. Yes, I have applied force, but net force was still zero because it got another force from wall equal and opposite. Okay, hello Janmijay. So next, see this. This test tube along with its skateboard was moving with a constant velocity. So before striking, it was moving with a constant velocity and net force on both of them were zero. Net force on both of them was zero. So there was no change in state. But see, this skateboard, now it is striking to a heavy stone. Heavy stone, that means a stone which cannot move, or you can say which is connected to ground. So when this skateboard strike to the stone has exerted opposite force on the skateboard, and the state of motion of this skateboard has changed from motion to rest. Okay, we can stop the motion if we exert force. So to stop the motion of this skate, the force is exerted by this stone, but the force is only exerted on the skateboard. The force was not exerted on this test tube. That is why the state of motion of test tube was not changed. It continues its motion, and due to which it falls and breaks. Okay, so this is another example for Newton's first law of motion. Okay, thank you beta Jack. So let us discuss first law of motion in detail. Janmijay beta, action reaction is the third law. We will study, don't worry. See, what is first law? First law, all of you know. A body will continue its state of motion until and unless an external force is applied on it. Okay, so this law is also called law of inertia. Now what is inertia? See, inertia, I am introducing inertia in this first law. See, inertia is a property by virtue of which a body opposes change in the state of rest and motion. Okay, it is the property of a body. And in second law, we will see this inertia is proportional to the mass of the body. Okay, so that means if a body has more inertia, it will require larger force to change its state. If a body has less inertia, it will require a less force to change its state. Okay, so this is the definition of inertia, which is very, very important. And one more thing, that inertia is directly proportional to mass of body. If you have less mass, you will have less inertia. If you have more mass, you will have more inertia. But what is inertia? It is the opposition to change the state. Okay, a heavy stone requires a larger force to change its state, but a lighter stone or a marble, it requires a less force to change its state. Okay, force is such a factor which is essential for change in translatory motion of a body. Okay, if you do not apply force, you cannot change the state of motion or state of rest of any body. The first law of motion defines the force. It defines that force is a physical quantity. Okay, physical quantity means the quantities which can be measured. Okay, so force is a physical quantity that tries to change or changes the state of motion. Okay, force either change or try to change the state of motion of any object. Now examples, some more examples of first law of motion. Banking of the passenger towards the motion of bus sitting in a bus on applying the sudden brakes. All of you know, many of you have observed this situation. Yes or no? Let me know. Have you observed this situation? while moving in your school bus, okay, post corona days, moving in a school bus, if the bus apply the brakes suddenly, see, initially all the passenger along with bus, they were in the state of motion. Now if brakes are applied, that means force is exerted on the bus to stop, but on the passenger there is no force exerted. That is why if we stop the bus suddenly, the passenger continue their motion, they continue their state of motion. Okay, that is why they feel that they are falling in the direction of motion. Okay, yes. So examples make concepts clear. In physics, if you only read theory, if you don't get any example, it will be difficult. But in this class, in this channel, I am going to take a lot of example to make physics easy for you. Okay. Now, let us discuss the second law of motion. What is second law of motion? According to this law, the rate of change of momentum of a body is proportional to impressed force, and it takes place in the direction of force. Now, what does it mean? You're welcome, beta Khushi. So, beta, like this session, all of you like this session, and subscribe this channel if you are new. Okay, so that you can get the updates of upcoming lecture. If you subscribe the channel and press the bell icon, you will get notifications of new chapters and new quizzes. Okay, recently I have taken a quiz and many of the students have participated. Now see, according to this law, the rate of change of momentum. First of all, what is momentum? As you know, momentum is a vector quantity which is equals to mass into velocity of the body. Okay, and direction of momentum is same as the direction of velocity. Okay, so according to this law, the rate of change of momentum of a body is proportional to the force applied. That means, see, if this is a body of mass m, okay, staying on ground, if we apply a force on this body, then according to this second law, this force is directly proportional to rate of change of momentum. What is rate of change of momentum? It is dp by dt. This is the second law. Okay, and what does it means? It takes place in the direction of force. It means that change in momentum has same direction as that of net force. Change in momentum has same direction. There is difference between Grimmerjack, it means applied force. Okay, there is a difference between momentum and change in momentum. Momentum is a vector quantity and change in momentum means final momentum minus initial momentum. Okay, what is change in momentum? It is very important. You should know. Change in momentum means final momentum in vector form minus initial momentum in vector form. So you have to do vector subtraction. Okay, vector subtraction you are required. So direction of change in momentum, that means direction of delta p, is same as the direction of force. Direction of momentum is not same as the direction of force. Direction of change in momentum is same as the direction of force. Okay, yes Janmijay, we will study about impulse also in upcoming lectures. So this is the second law of motion. Now all of you know, if I remove the proportionality sign, there will be a constant. Yes or no? There will be a constant. So F is equals to constant K, which is proportionality constant, into dP by dt. Okay, and the value of this proportionality constant that we have calculated experimentally, it is equals to 1. That is why we only write that F is equals to rate of change of momentum with respect to time. The law is force is proportional to rate of change of momentum, but experimentally this proportionality constant has value 1. That is why this force is equals to rate of change of momentum with respect to time. Now all of you know what is momentum. The momentum is mass into velocity vector. So what is rate of change of momentum? What is rate of change of momentum? Rate of change of momentum means if you differentiate this with respect to time, you will get rate of change of momentum that is equals to force. Now if you differentiate m into v, let me know in the comment section what will you get. If you differentiate m into v, what will you get? Use live chat and tell me. P is equals to mass into velocity, okay, and force is equals to rate of change of momentum with respect to time. P is the linear momentum, okay. So if I differentiate P, if I differentiate m into v, let me know what will I get. Yes, you can, Mohammed. Yes, you can. See, Kavya is saying we will get m into a. See, listen carefully. This is the most important point, that if mass is constant, all of you know the law of differentiation. If something constant is multiplied by variable, to differentiate we take constant outside. So it is equals to m into dv by dt. So this formula is valid only if mass is constant. If mass is constant, then only we can say F is equals to m, and what is dv by dt? What is rate of change of velocity with respect to time? It is acceleration. Force is m into a only if mass is constant. Yes, Janmijay, if mass is constant, then only we can say force is equals to mass into acceleration. Otherwise, we cannot. This is the most important point. If mass is constant, then only force is equal to mass into acceleration. If it is not, we have to differentiate mass also and use the formula of product of two variables differentiation. Okay? Good. Very good. Jack, miracle boy. Very good. So, but I like this session. All of you like this session, and hit the subscribe button if you are new, so that you can get the notification. Now, see this. Mathematically, we say that force, this is the same thing that I have taught you. See, if mass is constant, then only we can say force is equal to mass into acceleration. And as you can see, force is a vector quantity, mass is a scalar quantity, acceleration is a vector quantity, and there is no negative sign. See, F is equals to m into a vector. It implies direction of F and A are same. Okay, this expression means F is equals to m into a vector, and direction of F is same as the direction of m and a vector. Okay, m has no direction, so scalar multiplied by vector is again a vector which is having the same direction. Or in scalar form, we can write force is equals to mass into acceleration. Okay. Now, if mass is constant, we have studied what is second law. Second law is force is equals to mass into acceleration. Now, what does it mean? Listen carefully. I am giving you a good example to understand. See, why it is easy to move this stone. This stone is small. Okay, this stone is small. So why it is easy to move this stone? Suppose you have capacity to exert only 20 Newton. Suppose you have capacity to exert only 20 Newton of force. Okay, you have capacity to exert only 20 Newton of force, and suppose this stone has mass 1 kg. Then if we exert the force, suppose this stone is on back side, it is not in front of this stone. So if we exert force on this stone of 20 Newton and it is having mass 1 kg, then let me know what will be the acceleration of this stone. See, if we are exerting force, the mass of the stone is not going to change. So we can use this formula that F is equals to mass into acceleration. So what will be the acceleration? Acceleration will be force divided by mass, and that will be equals to 20 meter per second square. So we can say that if we apply a constant force on different bodies, if mass is less, then acceleration is more. If we apply constant force on different bodies having different masses, then the body having less mass will have greater acceleration. Is it clear to all of you? Khushi beta, this is dimensionally incorrect. The unit should be meter per second square. Okay. So this is the main point of second law. That means if our force is constant, if we apply different force on different bodies, the body having least mass will have greatest acceleration. Okay. So what does it mean? More mass means less acceleration. Less mass means more acceleration if the applied force is same. So it means that mass is the thing which is opposing the change of state. Is it clear? As I told you, inertia is directly proportional to mass. More mass means more inertia, means more resistivity to change the state of motion. Now think, see, this was the small stone. It is easy to move this stone. Why? Because it is small. Now if I talk about this big stone, suppose this complete stone is, suppose it is having a greater density, and this complete stone is having the mass of, you can say, let's take it 2000 kg, and still you have capacity to apply only 20 Newton. So if you apply only 20 Newton on this heavy stone, then let me know what will be its acceleration. What will be the acceleration of this heavy stone if you apply only 20 Newton force? You can use the second law of motion, that is force is equals to mass into acceleration only if acceleration is constant. Okay. So here mass is more, so definitely acceleration will be less because our applying force capacity is constant. So what will be the acceleration of this stone, this heavy stone, this very denser stone? It has very good density. So as you know, acceleration will be equals to force by mass. Force is 20 Newton, mass is 2000 kg. Okay, so it will be equals to 1 by 100, or we can say 0.01 meter per second square. So what is acceleration? 0.01 meter per second square. This is very less. See, in previous condition, by applying same force, we were getting 20 meter per second square. And here, by applying same force, we are only getting 0.01 meter per second square, which is almost negligible. You cannot even observe this acceleration. This is negligible. Good. Jack, Mohammed, Miracle Boy, Janmijay, Khushi, very good. That means if the applied force is constant, and if we are applying force on different bodies, then the body having larger mass will have least acceleration. Okay. Janmijay, practically there will be some friction force, but we will discuss about this later. Right now I am only assuming single force. If single force is applied on a body in this direction, it will move, but it will have a less acceleration. That means its velocity will increase very slowly. Okay. So more mass, less acceleration. Less mass, more acceleration. That means mass is that property which is resisting its state of change. Okay. If a cricket ball is moving towards you with a velocity of 20 meter per second, you can easily stop this ball by catching. But if a heavy truck is moving with the same velocity 20 meter per second, you cannot stop that truck. Why? Because state of motion is same for both of them, but the mass of truck is more, so more effort is required to change the state of motion of the truck as compared to a moving cricket ball. Okay, so that is second law of motion. And force is equals to mass into acceleration. This equation is only valid if mass is constant. Okay, yes, Miracle Boy. So better hit the like button and share this session to all of your friends, because I am going to take more quizzes after these kind of lectures, so it will be beneficial for you. More students means more competition. Now see this. If this man hit this elephant, the elephant will not get too much displacement. See, elephant has got the less displacement, but this man who was having less mass, he got the more displacement. Okay, so this means more mass means more inertia. Inertia, which is the property of a body. Inertia is the property of body which resist the change in state. See, this man has applied force on the elephant, and the elephant has also applied the same force. We will study this force in action reaction law, action reaction pair. If you apply force, you will get the same force. Okay, that is action reaction. So this man has applied the same force on the elephant, and the elephant has applied the same force on the man. But the man got the greater acceleration and the elephant got the less acceleration. Why? Because elephant has more inertia and the man has less inertia. And how inertia is related to mass? Inertia is directly proportional to mass. More mass, that means more inertia. Okay? And force is equals to mass into acceleration is only valid if mass is constant. Now, if we change the mass, then force equation will be different. See, first of all, let us talk about some important things, that force is a vector quantity and its unit is Newton. Actually, its unit should be kg meter per second square according to unit and dimension, but in the name of the scientist Newton, we call 1 kg meter per second square is 1 Newton. Okay, kg meter per second square is MKS unit, and see, Newton or kg meter per second square is same thing. Dyne and gram centimeter per second square is same thing. Okay, dyne or gram centimeter per second square is the CGS unit. Okay, now yes, well done all of you, good. Hello Kamlesh. See, dimension of force, all of you know how to find dimension. You know about the chapter unit and dimension. See, first law was defining the force, but the second law of motion is giving the magnitude and unit of force. Okay, now if mass is not constant, see, if m is not constant, then differentiation of m into v will not be mass into acceleration. You know, if we have two quantities which are variable and if we want to differentiate them, which formula we use? First function into differentiation of second function plus second function into differentiation of first function. That is the formula. So if mass is constant, we can take it outside, but if it is not constant, we have to use force is equal to mass into dv by dt plus v into dm by dt. And what is dm by dt? It is rate of change of mass with respect to time. Okay, if we talk about rocket, how rocket flies, see, rocket when it is flying, it releases the gases. So mass of the rocket, it is reduced. That is why it get an upward acceleration according to this equation. Okay, so we will use force is equal to mass into acceleration if mass is not changing. If mass is changing, if the rocket is releasing the gas, it is reducing its mass, then force, we will say it is this. Okay, Janvijay, it is. Sometimes we write the unit of stress like that. Now, the third law of motion. What is the third law of motion? It is very simple. According to this law, every action has equivalent opposite reaction. Now, what does it mean? It means that if I apply force on any body, the body will apply equal and opposite force on me at the same time. Okay, at the same time, action reaction pair, they act on the same time. It doesn't mean that if I hit the wall will follow me to hit back. No, at the same time when I hit the wall, okay, at the same time I will experience force by wall on my hand. So this is the third law. Every action has equal and opposite reaction. Okay, and see this. Suppose this is a wall, and this man is exerting force on the wall. Man is exerting 20 Newton force on the wall, and at the same time, wall is exerting 20 Newton force on the man. Okay, so this is action and this is reaction. Action and reaction are on different bodies. They are not on same bodies, and action and reaction are of same type of forces. The man has exerted force 20 Newton on wall. Wall has exerted 20 Newton force in opposite direction on the man. Okay, so action reaction pairs, action and reaction, they act on different bodies. Okay. Yes, Janmija, if you have anything doubt, you can ask. Now, see this. Let's talk about action reaction pairs. Some examples. See, suppose there is no resistive force experienced by this board due to water. Now, how do we walk? See, first of all, let us discuss how do we walk. If this is the ground, then how do we walk? What we just do, see, this is our feet, this is our foot. What do? We just try to push the earth in backward direction. Okay, we try to push the earth in backward direction. Okay, force on surface due to person. We exert a backward force on the surface, and because surface is stationary, and according to Newton's third law, the surface also exerts equal and opposite force on us. Force on person due to surface. Now, because the earth is having very large mass, so acceleration of earth is very less, it is almost zero, but we have some acceleration. Okay, due to this force, our center of mass move in forward direction, and that is how we walk on the earth. Okay, we can walk on the earth due to Newton's third law, action reaction. Is it clear to all of you? When we walk, just try to observe, when we walk, we try to push the surface back, due to which we get forward force and we can move. This is how we walk. But the earth has very greater mass. That is why, see, force on us and force on earth, they are same. Force on us and force on earth, they are same. But earth has very large mass, so its acceleration is very low. And we have a very low mass as compared to earth. That is why we got some acceleration and we can move. Okay? Clear? Now, if the surface is not stationary, if the surface has not greater mass, then the surface will move backward. And you can see this in this example. The man is moving on the board. The man is exerting backward force on the board to move. So man is moving in forward direction, and due to the backward force, the boat is moving in backward direction. Is it clear to all of you? Yes, Kushi, this is the second example. See, action reaction. To walk, the man has exerted force on boat in backward direction, so boat is moving backward. And because man has exerted force in backward direction on boat, man got forward force due to boat, that is the reaction at the same time, and he moved in forward direction. Next example. Example of firing cannon. See, whenever cannon fire a ball, cannon is exerting forward force on ball, and according to Newton's third law, equal and opposite force is experienced by this cannon. That is why it is moving in backward direction. Equal and opposite force. Opposite force means just 180 degree apart. The cannon has exerted forward force. The cannon has exerted force on ball, and force on ball by cannon, and this is force on cannon by ball. Is it clear? Yes, you can say, Dreamer, in rocket propulsion you can say, what does the rocket do? The rocket release the gas. Okay, the rocket exert a downward force on the gas, that is why gas can exert upward force on the rocket. This is how rocket moves. Okay, here the cannon is exerting force on the ball, at the same time ball is also exerting force on cannon. This is action reaction, and remember always, action and reaction takes place at same time but on different bodies. It acts on different bodies. Okay? If we hit the wall, if we exert force on the wall exerts equal and opposite force on us. So if you kick the wall, you will get hurt. Okay? That is due to Newton's third law. Okay? See this. When two bodies A and B exert force on each other, the force on first and the force on second, they can be written equal in magnitude, but because they are opposite in direction, so in vector form we write this: force on A due to B is equals to negative of force on B due to A. Okay, this is action and reaction. If this body is exerting force on second in upward direction, the second will exert the equal and opposite force in downward direction. What is the meaning of equal? Equal means equal in magnitude. And what is the meaning of opposite? Opposite means opposite in direction. Okay, see, the direction is just opposite. And action reaction always acts on different bodies. And this law expresses the nature of force. Nature. That means if the sun is applying gravitational force on earth, earth is also applying the gravitational force on sun. Okay, that means the nature of force will be same. Okay, there are so many types of forces that we will study. Now let us solve some question to understand this better. A body whose mass is 6 kg. Mass is 6 kg and it is constant. See, it is fixed. It is not changing with time. This mass is not as a function of time. It is a constant value. Is acted upon by two forces. This is the first force. This is the second force. In vector form it is given. First force is 8i cap plus 10j cap and second force is 4i cap plus 8j cap. Then the acceleration produced on the body will be. This is the question. So because mass is constant, we can use the second law of motion, that is force is equals to mass into acceleration. So first force is this, second force is this. So what will be total force? Total force you can easily calculate because you know about vectors. Force is a vector quantity. So total force will be the vector sum of these two. Okay. So total force is equals to 12 I cap plus 18 j cap. Okay. And because total force is equals to total mass into acceleration. Okay. And force and acceleration are vector form. So we can say acceleration is equals to force vector divided by mass. So if I divide this vector with mass, which is 6 kg, I will get the acceleration. So this is the acceleration in vector form. Okay. And if you want acceleration in the magnitude of acceleration, it is very simple. Just under root of this x square plus y square. So it will be equals to under root of 13 meter per second square. This is acceleration in vector form and this is the magnitude of acceleration. Okay. So this was a simple question. See the next question. A car of 1000 kg moving with a velocity of 18 km per hour is stopped by the brake of force 1000 Newton. Then the distance covered by it before coming to rest is. Okay, this is the question. So see this. The car, it was moving with a velocity, it is given 18 km per hour. Okay, this was moving, the car was moving, and suddenly what happened? It stopped by a brake. Definitely the force to stop this car, the force should be in opposite direction, because in the direction of force the acceleration is there, and in the direction of acceleration the velocity increases. Okay. So force is in backward direction. This force is due to the friction, which we will study later, how friction stopped the body. So see this. From the relation force is equals to mass into acceleration, due to this force of 1000 Newton. Okay, what is this, the value of this force? 1000 Newton. Due to this force, the acceleration on this body will be in the direction of force. And because acceleration is just opposite to the initial velocity, there will be retardation. We will say acceleration is negative. Okay. So acceleration is force by mass, which is equals to 1 meter per second square. Okay. As the force is brake force, acceleration, we will say it is minus 1 meter per second square. Now using the relation v square is equals to u square plus 2as. Why we are using equation of motion? Because acceleration is constant, and when acceleration is constant, we can use equation of motion. Okay. So we obtain, see, this initial velocity is this, final velocity is 0, and this acceleration is equals to minus 1. So by this we will get this u square is equals to 2as. Okay, this minus 2as, and acceleration is minus 1. So we will get s is equals to u square by 2a. Okay. So by putting the values, we will get the distance traveled by car. Okay, this distance traveled by car to stop. Here its velocity is 18 km per hour, and finally its velocity will become 0. When the car reaches here, its velocity will become 0. So it is asking the distance covered by the car to stop, and it is equals to 12.5 meter. Dreamer Jack, see. Listen carefully. Normally we take these axes, x-axis and y-axis. So u is positive, and because acceleration is in the direction of force, acceleration is negative. Okay. Now next question. See, the theory is over, but if you solve a lot of question, your concept will be clear. As I told you, in physics, only theory is not sufficient. You have to practice a lot to get the perfection. Because in physics, a lot of mathematics is there. A man fires a bullet of mass m each. This is a good question. With a velocity v. With the help of a machine gun. If it fires n bullets, it fires n bullets every second, then the reaction force per second on the man will be. That is the question. See, let me draw the diagram. The diagram will, by diagram you can imagine very easily. Suppose this is the gun. Although it is given machine gun, but I am trying to draw this shotgun. Okay. If this gun is firing bullet, so see this, the velocity of bullet is v and its mass is m, because this bullet was initially at rest inside the gun. So if gun is firing the bullet, that means gun is exerting force on the bullet, and due to this force this got a velocity v. Due to this, the gun will have backward force. Force on bullet by gun is this, and force by bullet on gun will be this. So we have to calculate the force in terms of m, v and n. Okay, so this is a very good question. Now listen carefully. As we know, force is equals to dp by dt. Okay, rate of change of momentum. So in easy method, we can say momentum given to each bullet. How much momentum is given to each bullet by the gun? It is equals to mass of bullet into velocity given to bullet. Okay. Momentum given in 1 second. Momentum given in 1 second. Each bullet, the momentum is m into v, and it is firing n bullets in 1 second. So in 1 second, the total momentum given by the gun to the bullets will be m into n into v. Okay. And what is force? See, instantaneous value of force is dp by dt, and average value of force is equals to change in momentum divided by the time taken to change the momentum. Okay. So I can say change in momentum in 1 second is equals to force. Change in momentum in 1 second is equals to force. So momentum given in 1 second is equals to m and v. So we can say force exerted on bullets is equals to m into n into v. Force exerted on bullets, because we are giving m and v momentum in 1 second. So force will be m and v. If I say momentum given in t seconds, that will be m and v into t, and momentum given divided by time t will be m and v. So force is what? It is m n into v. So force exerted on bullets will be m and v, and similarly force exerted by bullets on gun is same m and v, but in opposite direction. So what is the answer? The answer is force is equals to m and v. You can also solve this in this way, that momentum given in t seconds will be m and v into t, and time taken will be t. So force will be equals to m and v. This t and t cancel out. Is it clear to all of you? Okay. Yes. Jack, yes. So, see, since practice is very important, and that is why I am going to give you a lot of homework question, so that before coming to next class, you can practice these questions, these topics, and in next class, we will start with a different topic. See, you may think that all the 3 laws we have studied today, so is this chapter is ended? No. In this 11th class, along with the laws, along with the statements, their application is more important. Okay. So in upcoming lectures, we will use these laws in different situation. Okay, as per our syllabus. So I am giving you some homework questions. This is your homework, and its solution is given. This is again your homework and its solution is given. Homework, this is also your homework. Okay, so that is enough. These questions will be enough to understand today's lecture. Now, how can you get this homework question, these homework question? You can get all of these that you are watching here. All these presentation will be given to you in form of PDF, soft copy, through this eCareerPoint app. So just download this eCareerPoint app, and after downloading from Google Play Store, just follow your experts, because once you follow your experts, you will be able to attempt the question posted by your experts, and inside this free stuff you will get all my lectures along with the notes which is given in PDF format. Those slides you can see here along with my written annotation you will get in this free stuff. Just go in this free stuff and select medical first, because I am teaching for NEET, and see this. Here you will find class 11th physics NEET 2022 English medium. Click this and you will get all my previous chapters lectures along with their respective notes. Okay, Khushi is asking for the timing of class. See, I take these 11th class on Tuesday, Thursday and Saturday 3 p.m. Okay, although you can also watch my previous lectures because they are available on YouTube, but it will be beneficial for you if you come and attend the live classes. Okay, so I want all of you to hit the like button, those who are live right now, because it inspires us to give you a lot of good content. Okay, hit the like button. If you are new, hit the subscribe button and press the bell icon so that you can get all the updates of upcoming lectures and upcoming quizzes. Yes, I take online quizzes also, in which you submit your answer and I display the results on the board. Okay, so share this session to all of your friends so that everyone can participate. More student Menti quiz will be more competition. Hit the like button, all of you, and if you want any other information, do let me know in the comment section. I personally read all the comments. Okay, so that is enough for today. This is Sumit Talwani signing out. Thank you very much.